example. And so I wondered, why can't we use this stuff to enforce our own rules that are domain-specific? It's not something that is language-wide, so it's, let's call it horizontally, so that spans all over any business, but is specific to our business. And one of the most simple examples that came in my mind is the serialization example. We all know that there are times in which that you have an entity, and you don't want that the default constructor is called just because in the constructor you have to do something with the complete parameters. So you don't want to have a special type. You want to have a complete type with all the parameters and all the properties correctly initialized. They don't want just to have a new customer open and a close bracket and having something that everything is null. Okay, is something that it does not work well in your business. At least it happened many times for me. The solution is, of course, to create a custom constructor. So you simply specify all the parameters with the customer that specify ID and name and so on, and you are done. But there is a problem that this way you end up having the problem with your serializer. And so you begin screwing up with the JSON serializer, with the JSON converter, because you have to be customer aware in your deserialization, otherwise it will screw up. There are other solutions like adding attributes, and JSON.NET provides several additional workarounds for this. But you end up having dependency that you don't want to, and so on. So the basic point is we should really go with the custom deserializer, or we can do something during development time. And the answer is very simple, because we can go to this sample solution and, for example, having this very, very simple logic that is create customer, and then create a customer, and then make this, this entity happy, or this one, or even this one. And we just want this to be valid, while the other, it's better that we don't use, because if we forget these two properties, we are screwed up, and our logic is not going to work. So what I'm going to do is to add an analyzer that will give me a developer experience that provides me some squiggles that you can decide to be either a warning, of course. And the default error, the default warning is the default error, the default constructor are reserved to serializers, which is, of course, a rule that doesn't exist in C#. Is not something that makes sense in a general case, but can make sense to your specific domain, okay? It's not something that I have to recommend in any case, and not a solution that will be always this the perfect solution, but it's definitely interesting to see that you can provide this kind of solution. And also, even if you initialize the entity this way, of course, we are using the default constructor, and this will trigger the error the same way. And the kind of solution that I created in this analyzer is simply the domain model constructors. I register for an operation, which is the object creation in my analyzer. And the analyze operation is going to receive as a callback any kind of statement that is of type new something, okay? And it's up to me to find if it's the correct one or not. So I know that the kind of operation is the correct one or not. So creation, I know that the kind of operation is operation to this one. I take from the metadata the interface identifier, which, by the way, is a sample library iDomain identifier, a simple string. And I will obtain a iNamed type symbol. So I obtain a symbol so that I can match and see if the symbol is exactly the one that I am analyzing. So I am not disallowing the default constructor for any type, which will be, of course, wrong. I want to enforce the rule just for my type that implement an interface, which, by the way, is empty. It's just a tag, OK? It's not something that contains members to do anything else. If you want, yes, but it doesn't matter. It can be absolutely empty. Or if you prefer, can be an attribute, OK? It's up to you to decide how to recognize the exact types. An interface is quite a good solution for this. And if the type that I am analyzing, which, by the way, is the type that is going to be constructed in all in the interfaces, searching, OK, I am going to apply this diagnostic. And so I am just checking that I want to enforce the rule if I have no arguments, because the default constructor is there. And so I find the location of the syntax. I create the new diagnostic with the rule that I something that you can do very easily. And what about going a bit on a more concrete example? Let's take an example where you have an SDK that push commands and events on a bus. And I want to send either a command on or an event. In the newer architecture, I don't want to lose time in explaining what is the case specifically, but it is very common to send over the bus events and commands. And you basically have just a push from the bus perspective. It does not make any difference. So you will, of course, serialize the stuff and send over the bus, deserialize over on the other point, and is done. But probably these two APIs, send and publish, will do slightly different things, because internally you can have the priorities of the queues and many other parameters that makes a difference. So maybe they are broadcasted or sent to a specific endpoint. So the first case is simply, I want to define my bus manager with publish an event and send with a command. And that's perfectly fine. I mean, it works very nice. The problem is that you end up in defining an interface on which everyone will take dependency, and we know that dependencies on large projects are definitely a problem. And maybe in a later time, you end up in having an interface which will need to be shaped slightly differently. And so, yes, it's an I command, but I have to add these members. Or maybe I don't want these members to be there. Or why should I care that I have to shape my command? I want to accept anything to be a command, because after all, and we end up in making philosophical decisions which are the worst from the design perspective. Okay? So I don't want to discuss the case. Maybe half of you agree with me on this discussion, and maybe not. Okay? But the point is that depending on the domain, you may have decisions that you cannot take at design time. Okay? It's something that is difficult. So the only way where you can get rid of the common interface is to define the object. I mean, why not? And the reason why not is the reason why we don't use JavaScript, right? So we love the type thing. And it's definitely a good solution, because also many JavaScript developers transitioned to TypeScript for a reason. Just to have only at design time, not later, it doesn't matter, but at design time, we want to have the types, right? So the point is, I can still define the object, but I can also give a better user experience by providing another analyzer which squiggle when I try to put an event on the send or to put a command on a publish. And this is a pretty good solution. I mean, why not? After all, we are providing the types just for the developer that is using that API. because at runtime it doesn't make any difference. So if I can stop the developer at compile time, it's good. And not only I can do this thing, but I can also fix, and you see the suggestion to replace the send with publish, and okay, I just fixed the logical error, the domain-specific error, okay? I want that my SDK is used this way. I am driving, I am helping, I'm giving documentation to the developer to use the SDK in the correct way. And the implementation is pretty straightforward. I mean, there is really nothing so complex. There is an analyzer that basically knows about various types. So I know about the IBUS manager, that is the type that will expose the send and publish. I know that send is for iCommand, and the parameter is index 0, so this is the first parameter. And the publish is associated with the iEvent, and the index of the arguments is 0. So I register my operation with the invocation, which is basically a call, okay? We are invoking something. And when I find an invocation, I know that I have an invocation operation. And this, I take the data, so the method name, the method symbol, and the type, the bus interface from the metadata, and so on. And I go to check what's happening there. So if the type is the correct one, because I don't want to apply this rule on all the types that I am looking at, I simply checking if the argument's length is greater or equal, greater of the send parameter index, which is by the way 0, we said. And I have to check the argument. So I have the semantic model that is the one that converts, let's say, the syntax in symbols. Okay, give me this additional information that allows me to understand what the specific symbol is telling me. And then we analyze the symbol. And if is mismatched, is substantially the argument is not null, is not of the correct type, and does not contain this type, because it can be derived or implemented in the interface in any way. Okay, at this point I take the location, I take the diagnostic, and report the diagnostic, and the squiggle, the green squiggle, is showed to the user. And the same, exactly the same code applies to the publish method. On the other side, when I click on the light bulb, I have the code fix. And the code fix substantially receives the information from the diagnostic, from which I extract the span, so the interval of the code, the text of the location. And I register the code fix so that the change bus method is called with all this data, including the cancellation token, which is very important because everything that happens inside the IDE must be asynchronous, of course, and must be possible to be cancelled. So the change bus method basically takes the same information that we took before in diagnostic. We have to search then again, and once we have the invocation, the call that we found before, we extract the member access. The member access is substantially when there is the dot to access a member. Okay, so we have the left side, which is the variable which we are accessing. The member name is the name of the member, of course, and the arguments that the list of the arguments that are passed to this method. At this point, once I have the old ones, I have to create a generator based on the current document. So I created the code generator, and I start generating new code, okay? So the first thing is to call my own logic which I don't want to drill into because it's clueless. I mean, it's just my logic that say if you find a send, there must be an I command. If I find a publish, there must be an event. So it's just to find the correct couples, so the tuples that are important. So the new member name suggested for the argument that I found in the code is the new member name. And so I create the new member with this identifier, thanks to the generator. Then I create the new member access expression where the left side is the same and the new, of course, is the new member. And when I return the updated document, I'm done. So I have the replacement. It's not that bad. Now, a poll. Do you agree as a good solution? Who agree? Okay. Not too much. I still didn't convince you. But I want you to take some time and let's see. So this is nice. And there are the classical analyzers. After all, there is nothing so super new. In fact, the analyzers are there for a while. I mean, it's not something that is tremendously new. And what we have seen now is that the IDE is walking your syntax tree. Is the Visual Studio, if you want it, works also on the Visual Studio code, by the way, calls you and informs you about the node that are found
да все нормально.
code. So
Там одну утилиту надо написать, она немного сложноватая такая. Но, в принципе, я напишу, потом, может быть, продолжу стримить и создавать BerylEmu. Пока проект в таком отпуске небольшом.
That's pretty bad because, of course, there are many other information that can be relevant to what you are executing.
Надеюсь,
so,
меня было
example, if I want to know what has been executed, potentially executed before a certain call, you have to go back in the code. So,
если хочешь, заходи в диск, поболтаем.
Did code review, you know that you start from a certain specific point and you end up to go in a totally different project, and you walk by and you spend entire days in walking the code by hand, either with F12 or if you use a Sharp or other keystrokes, it doesn't matter, but the point is you have to walk the code to understand what's exactly going on. So the analyzers are pretty close to this because they cannot see the entire solution. And so my solution is instead to write a custom tool. So basically the same API, but you start from a console application. And that can be run, of course, on the build server or standalone if you want. The first thing that we have to do is create a console application, for example, but it can be also a graphical interface, of course, that use this build locator that basically wraps the work to find the correct version of MS Build. You know that versioning of MS Build is kind of mess, so this is the correct NuGet package to start from to find the correct MS Build stuff. And once you have compiled the solution and there are no errors, and this is done by Roslyn because Roslyn is our compiler, is our everyday compiler, we process the syntax and of course we extracted the semantic information with our code. What we are seeing, what you are going to see is how do we walk the graph. So there is an important information that I have to give to you because it's very, very relevant. When you walk the graph statically, it's totally different than walking the graph at runtime. So for example, when you have a call that contains a try catch finally, in a static call you don't know what is going to happen at runtime. So potentially you are going to execute both the try and the catch and the finally. But maybe your test doesn't never throw, and so you will never end up in testing the catch. Okay. The advantage of the code analysis is that you always have code coverage that is 100%, because you end up in visiting all the nodes that are ever possible, even the ones that are potentially illogical. Did you ever experience the classical case? How is that possible? You know that, no? It was supposed never to go there. It was impossible. No. And your friend on the other desk will go, oh, it's absolutely impossible. We know that it's possible because the logic is the logic. There's always the chance that something happens. The advantage of the code analysis is that visiting the tree, you will end up in having, yes, this crudity. I mean, it's a crude information where you visit everything, even if it's potentially illogical, okay? Unless you do a specific check for constants, I will visit also the while false, just to understand between me and you. So if you have while false, invoke that unless you check specifically, and it's possible to exclude the cracking code analysis because it's a constant. So when it is a constant, it's done. But if it is inside a variable, and there is the chance that anyone can modify that value, the Boolean value to true, you will receive the message, okay? So, the most important part is that when you want to walk the tree, you have first to start from a certain point, which is the point that you want to diagnose, and then you have to walk up the tree. Why? Because if we have here something that is relevant to you, maybe before, maybe here, it happened something that is relevant and can make some changes at this point. So it's basically we have to reconstruct basically the timeline of execution of everything that can be potentially executed. Okay, so when the application will start, if it's starting in this node, we'll execute this first, and then this, okay, this one, and then this, and then this, and so on. So it's absolutely important to walk up the tree. And this is done very, very easily because in Roslyn, we have this find colors async that is a kind of a shift F12 that gives you all the reference that will invoke that specific. And we will see it. And then we will down the path because at this point we want to see every node that can be potentially involved in our code. But if we start from the very beginning of the tree, we will have exactly the full graph that is relevant to the method that we picked up at the beginning. Okay, and this is basically a recursive call because you will see in a moment we are inside a visitor, and this is offered by Roslyn. Okay, and as soon as we find an invocation, we ask to Roslyn, okay, I found an invocation, and this member that I am invoking, is it available as a declaration? So, do I have the source for the declaration? If yes, I will recurse, and I will start again in visiting it, and so my chain is completed, and I will end up in visiting all the graph. I will show you in the code, which is perfect. So, let's close this part. I have this first scenario. I will skip this build helper, which basically deals with the MS build stuff, and give me the chance to open a solution entirely and ensure that it's compiled, and give me, thanks to this my helper object that is called the inspector context, makes the compilation available and give me the symbols for all the possible nodes. This is the kind of helper that avoids to mess up and time asking again and again the object that I needed. The first visitor I want to show you is the get members. So the get members is very nice because it's it's a visitor that allows me to extract all the members that are included in my solution. And this is a kind of first interesting thing. From this, I basically have the static method which instantiate the visitor and cycle across all the project of the solution and add all the members extracted from that. And so basically recursively it's called in all this part until I begin visit my visitor. This is the member extracted visitor is the same guy, but this is static and I'm renewing it because it derives from a C# syntax walker that gives me the opportunity to walk a syntax tree, which is very, very good. What I did, I simply overrided two methods. So I overrided the visit method declaration and the visit property declaration. And once I have this, I can see all the declaration for property and methods. That's it. I am not interested in all the other syntax, and there are very, very long list on this. So if you make override here, you will see that the list is super long, okay, with all the possible syntax nodes that you may want to use. Okay, so the first one that I'm going to show you is this scenario. We already have a breakpoint.
Он дела идут.
It's recompiling because I wrote it first.
Надо было покрыть.
Okay, members, and you see that I have a lot of members here that are declared in my sample solution. Okay, and I want to filter them for order. So once I collected all the members, I simply create a link query and I say, okay, I want just the method declaration. I am not interested in properties. And I want the one whose name identifier contains the filter, so order. And then I take the entire declaration thanks to an helper that gives me also the parameters of the invocation and so on. So I end up in
походу
this nice list.
за показ такого ника меня забанят на YouTube.
Okay. So I extracted everything, every method that has order. Cool. We are done with this. It's nothing specifically complex. You have to see that method extracted visitor is very simple. So let's go on and go to this other scenario. And this other scenario is going to take the member and start from process business rules. That is a specific method that we have here. Okay, so this is the method. And we have two references, but they are located under the same method. Okay. So let's see what happens. So I basically take these members. I take the only one that is process business rules, and I walk up the tree until I found the referenced one.
Вот это пас неплохой.
And now I have the top members that are this one, and if I make a nice string for that, I basically find just prepare orders. Bear in mind that is extremely important, and start did find two invocations, because inside this, that is not a visitor, by the way. You see, I call it visitor, but it's not a visitor because it's just sufficient to invoke the find caller async we discussed previously in the slides. I receive one reference with each location. So I have one caller, but with multiple locations. So if I want to distinguish the first both invocations, I can. But at this moment I am not interested because I am just working up the tree, and I'm not very interested in knowing how many times is this calling. Okay, so let's go on in this. So we walk it down, then we walk it up, and then we finally have a more interesting example, which is the most important part. When I am here in this picture, I will basically start from the given method, walk up the tree, and then will descend all the possible trees that all the paths. And these are basically all the methods that are called inside my solution, and they are quite a long number. They are 93, okay? And you see also the call to next double, list add range, and so on. There are multiple things that happens inside. It doesn't really matter to us at this moment what is doing that logic. I mean, it's a logic that populates some entities. It's very simple, it's straightforward. But the point is that I know exactly what is the sequence of the course, because I am working the graph in a specific order. In order to work the graph in a specific order, the most important thing is that when I visit the node, the visit invocation, I first visit the base, and then I write my own code, so that I explore the graph, the path first, and then I continue to recurse, because otherwise the visit doesn't happen in the correct order. And once I am here, I visit and I see if there is, I take the full name and I add my search. And I recurse on the method declaration as we said before. So this is pretty straightforward. Let's go back to the scenario. So the second one is that I specifically asked to filter by this rule, and this is again pretty similar. And the idea is, as we switch back to the example, I have this kind of rule, this rule, okay, just a tag, nothing more. It's referenced by a couple of business rules. The first is apply an agent rebate. And the second one is the discount, the normal discount. And I don't mind about the implementation. As you see, it's not implemented exception because I am not running this logic. The most important thing is the code. Okay? Since I am not running it, I specifically on purpose left the not implemented exception because I am not running tests at this moment. Which, by the way, you should continue to run. I am not suggesting that you should not make any tests. But I am trying to understand the logic before the tests, okay? And my rule is that in my specific domain case, I don't want to apply and discount twice. And I want to find that bad and difficult thing that is, what about if I write some code that applies the discount, and then my code is taken by someone else who doesn't see my apply discount and apply the discount again, but in another piece of the code. And then maybe I want also another rule that is able to distinguish and tell me, yes, I don't want that the agent rebate, which is a discount, by the way, happens before the official discount. Because if you make a discount of 10 plus 5 and 5 plus 10 is different. I mean, you cannot swap the discounts. So the order of the discounts matters. And this is the business rule we are trying to understand. So what I am doing here, okay, again, it's a visitor. And this visitor is starting here with a visit. And I start with the invocation expression. On what? On the top. Because I have to find most of the story. So I have to start as soon as possible on all the available source code that I have in my solution involving a specific method that is applying the discount. So I go backwards in the graph. I find the top, and I walk to see if there is anyone else that is invoking this count in my case. And so I walk there, and if the type is tagged, and this containing type is this rule, I add the method sequence that I found someone that is using this rule. And as soon as I find the declaring syntax reference, I recurse and I walk all the graph. So what I am finding at this point, I am finding a sequence of 6 apply in the correct order. So if you were going to execute the code that I wrote, beyond the not implemented exception, of course, you will end up in having the execution in this exact order. Okay? So we don't only found the dependency of the codes, but also the order of the execution, which is extremely important. Now what? Now what? The problem is that there is a flaw in the logic of the tool. Because what if I am applying these rules on different instance orders? You get the point? So maybe I am creating in the same logic 2 different orders. And I am applying 3 times on one order and another 3 times on another. And you went, how can I know, since I am doing a static analysis, if these orders and these others are different or not? If you think about it, it's definitely possible. Because when you do a code review, you end up in distinguish it. Because you see an assignment. Okay? You assign the reference. You call a constructor of a new order, or you call a factory of the new order. But you see that there is an assignment of a specific reference that is the one that you are using inside the apply discount. So, what is happening here? The point is that I can create a more sophisticated analyzer that deals with a stack of dictionaries that are basically the frames of the identities of the reference that I found inside the code. So if I take all the symbols, I see the types, and I put them in a dictionary by name, okay, it's valid, it's legit, because the name counts, so the dictionary is a good candidate. And every time I invoke some code, I push it on the stack. And then I pop when I come back. I have the exact identity of each variable, each reference that I am using. But I have to do another thing that is extremely important. I have also to rename the name of the variables every time I enter the call, because I pass you an order, but you locally call the variable, and you call it with another name, and you call my order or O. Okay? So every time you call, you have to map the arguments with the parameters. The arguments are the one on the invocation. The parameters are the one you receive from the local call. And this is what I am doing here, which is pretty crazy. I told you, I advised you at the beginning of the session, you wanted to stay here at any cost, and so you have to bear with me. And now we have this start internal. So I create a frame every time a call is made. We will see this in a moment. So we push the frame, we visit the method, and we pop as soon as we exit. And every time we found an invocation expression, if it's the correct type that we found, of course we take all the things that we need and we push the method in the method sequence, but with the variable identity. This variable identity is something that I extract specifically every time I meet an assignment that we will see in a moment. And then on declaration syntax, of course, I take all the arguments and I put in all the variables and their recurse. In the assignment expression, basically, every time I don't see the variable identity inside my code, okay, and I extract by name from the dictionary, I am creating a new variable identity. And this variable identity is a class that I created, which every time I create a new one, the ID is automatically incremented. So I distinguish it with a number that is indefinitely goes on and on. Okay, once I have the new identity because I assigned the new reference, I recurse, and I am done. And when you have the declaration, the assignment, or the declarator, so var x equal order that you had before, is basically the same task. So this is a code that is pretty much the same as before. The good part is that this is sufficient to track the identity of the references. Of course, I didn't put in my code things like out, or anything else that can impact on the variable. So in a production case, you should take an account also those. And the result of the code of the execution is that is that you have this apply grouped in a different way. So we are loading the solution. The part that is pretty long is loading and compiling the solution, of course. You see that analyzing is not that bad also because the solution is pretty simple. And once I see the result, you can see that they are grouped by 3. So if in the code there are 3 applies in different places on one specific order, and then I create and reassign the new reference, and I reapply again the 3. Now, the validation on this business rule is pretty straightforward. It's just up to me to establish if it's legit or not, to respect this order in applying the rules, and whatever else you want to do with that. Does it feel better? Yeah? Okay. We will discuss later. Okay. So what we have seen is that, yes, it could work. It's crazy. It's definitely a strange thing to do because we are simulating the execution, but in a different way. And of course, we will never know if a discount rule is applied multiple times because of the loop. So we have to take an account of this, right? So it is specific to certain scenario. It's not a general rule that we can apply in every case. So it's up to you to evaluate if it's so this is basically the way to explain how to tracking the identity of the specific references. So I will jump up and let you on the slides. And I want to recommend that the analysis that you can do is obviously broader than the one that you can do with the runtime. But there are limitations. And as I said, you are analyzing everything, but you don't know exactly what will happen at runtime in terms of number of loops or many other things, or parameters that you are dynamically creating. If your code is specifically very complex because you are generating code, you are making anything else, okay, you should be very, very careful for this. So it's not a replacement for test, but at least it can give you a first boundary and say, okay, I already found this one. I will leave the other checks in the unit tests, so that I have a better coverage of that. And I have another interesting example that is if you walk the solution, this is pretty nice. If you walk the solution and you end up in having the entire tree, okay, with this member extractor we take the members, then the process order, and we go to the top members, and we run all this stuff. And we will end up in having this flow 1 WST, which, by the way, is a nice way to visualize the thing. It's a text file that you can see here. And if I go to the preview mode, this is plant UML, which is able to give you a sequence diagram. Oh, now, this is done on all the CLR calls, which is pretty boring. But if you filter out by your specific interfaces, or better if you go and extract only the calls that make you sense, for example, pushing something in the bus, you don't know what happens next, okay, from the CLR perspective. So you don't have invocation, but you can reconstruct the flow that you are doing on the bus, and so you can create a sequence diagram on the call that also involves external stuff, so like HTTP calls or even pushing events or asynchronous calls and so on. So this is extremely interesting because you can really see what is going to happen here. And you have the complete flow regardless of the try catch and whatever. If you want to filter out some of the paths, it's up to you. I mean, it's definitely possible. The last thing that I want to show, and I will close very soon, is that there is another use case. That is the one where you want to use a kind of eval to generate code and use code provided by the customers. It's something that you should never do, of course. But if you really have to, you can evaluate the source code by visiting it and understanding if it belongs to a namespace that is potentially dangerous. So I don't want that anything from system.io be executed in my code. So if your SDK provides a plugin and you give the interfaces to create new plugin, you may want to stop any call that is executed in that namespace. And basically, this is what is done with this last example. Okay, that's F5. And I will show just the output because the rest is pretty straightforward. There is the same way of listing the invocation and recursing. And on this first piece of code, you have basically, okay, the line and the column, write all text, not whitelisted, and it reports also that the line of code that was stopped. Basically, you're adding some rule to stop the compiler, and inform the compiler that it checks that, and you don't want to execute that line. So it prohibits certain calls. Of course, you have to also blacklist something. The whitelisting is always the best strategy, but you also blacklist the activator class, because the create instance name can do a lot of damages, and also the dynamic keyword, because the dynamic calls are unpredictable from the source code. So these are the two recommendations, and if you want to discuss this time, I will show additional code about this stuff. So to sum up, I can say it's definitely different, the flow, from the one that we are used to analyze at runtime when we use the tools, or from the one that we normally use as developers with our standard IDE. It's totally different perspective, and we are analyzing something that is specific to our business model. So we have code graph, we have sequences, we have the analysis of the dependencies, and especially I want to recommend you not just the dependencies from the CLR perspective, but from our domain perspective, which is not that and interesting. And we have seen the whitelisting and blacklisting from a security perspective. Of course, it may result in false positives. So you have to take it with, you have to be very careful in using it. And but it's definitely something that you can add and provide a better experience as soon as you go on. So
Ничего себе, вот это бомба.
And the result that you can obtain is definitely interesting. I hope that you are
Просто 0 секунд.
It's an idea to explore, of course. It's not something that is a general rule. And I want to thank you very much for your attention and following to the discussion zone if you have any questions. Thank you.
О, неплохие коллеги.
Thank you very much. So the speaker will be now available in the discussion zone number 1. So when you will exit the hall, please go to the left.
Был заблочен.
Мы продолжаем наше интервью. И сейчас у нас будет
Да ладно.
Роман Неволин и Вагиф Адилов. Господа, насколько я понимаю, вы оба состоите в программном комитете. Так?
Ух ты ж.
Да. И Мишка тоже состоит в программном комитете. Да. У нас получается такая, как бы, структура программного комитета минус я. Давайте обсудим насущные все дела. Как вам программа?
Ну, давайте я начну. Программа у нас стала лучше, чем в прошлом любом году по нескольким пунктам. У нас было пара целей, мы очень хотели наконец-то развить нормально по темам, чтобы у нас были не только какие-то конкретные темы, которые у нас много классных докладчиков типа перформанса, а было много всего. И вот в этом году, у нас, кажется, первый раз получилась такая программа, что мы действительно очень много всех тем, то есть мы взяли, там, не знаю, от каких-то квантовых компьютеров до того же самого перформанса, перформанса с разными вещами, как конкретного, так и регулярного. И все это вот в программе соединили. То есть у нас просто случилось, что у нас было 2 дня программы, в отличие от конференций старых, что у нас было очень много заявок, больше 100. Да, у нас прям хорошо много. Заявки были многие от топовых спикеров, мы выбирали не просто из каких-то докладов, прямо из лучших докладов, выбирали конференцию, те, кто нам еще и по темам приходили. В итоге у нас получилось много лучших докладов, много людей, которые там членов нашего программного комитета, какие-то авторитеты, не знаю, вроде того же самого Александревского, от которого Андрей он страшно в восторге. Да и я, в принципе.
И ему даже пришлось прекрасно было.
И многие другие. То есть программа прям великолепная, по-моему. Хотя посмотрим фидбэк, конечно, конференции.
Неплохой был.
Очень даже. Я тоже очень доволен программой в этот раз, что она получилась крайне сбалансированная. И здесь есть такой немножко отрицательный положительный момент. Мы, к сожалению, нам приходилось отказывать реально ребятам с хорошими докладами. Вот. Но плюс, я надеюсь, многие из них попадут на московскую конференцию, потому что там хорошо проработанные темы, хороший доклад, они просто не смогут эту секцию вставить. У нас уже был доклад на похожую тему, и они как бы попортили у нас структуру. Два очень похожих доклада. И, на мой взгляд, программа получилась.
Да ё-моё.
Так да, самый страшный момент это были, когда мы выбирали между двумя отличными докладами. Они просто были по одной теме. Про сервис у нас было докладов 6. Про контейнеры тоже где-то того же порядка. И мы вот смотрим, доклады отличные. Мы по каким-то мелочам их буквально сравниваем. То есть, чтобы они поменьше пересекались с другими, чтобы вот получше спикер подавал тему. А так смотришь, но оба доклада отлично. Хочется программу взять, хочется, но уже никак.
Дополнение.
Поскольку я первый раз могу участвовать в университете, то мне не с чем сравнивать, но каждая программа лучшая. По крайней мере, рад, что с моим подходом она не худше. Но вот из этих впечатлений был действительно очень такой большой комплекс. И насколько я понял, что это сильно означало эту конкуренцию более ранних, что действительно вот много сильных европейских докладчиков, сейчас отказывают, при этом очень много российских докладчиков с очень конструктивными докладами. И единственное, возникает чувство, когда отказываешь, мы порой отказывали тем, кто потом вот такой по контейнерам, по движкам, акрам, то, что нам все это уже было. Но вот в этот момент, тем, кто был на всех конференциях, конечно, слушай, но все хорошо, конечно, очень много нового. И здесь важно не уйти такого совсем хардкор, мы все видим, у нас есть и многим с самого начала важно баланс.
То есть есть какая-то квота на доклады уровня смузи, например. Они обязаны.
Да, у нас в этом году как раз была еще квота на доклады разного уровня. То есть помимо того, что у нас были квоты на доклады разных тем,
Да ладно.
доклады по
Даем.
Тоже было, мне кажется, очень сильно да, у нас, в общем, не вышло сделать по этим квотам, а в этом году нормально, мы более-менее близко держались, да. То есть у нас должно быть не слишком много смузи докладов, это такая отдельная категория, должна быть там около 7, условно говоря, да. Вот, а для практикующих инженеров тоже писать доклады, что-нибудь порядка 15, потому что это самая интересная часть, то есть то, что можешь взять и использовать на работе, собственно говоря. И хардкор — это тоже такая важная часть, но должна быть очень много. Потому что хардкор — это тема, которую большая часть аудитории с хорошей вероятностью может не понять.
Даем.
Да, не будет смысла применить. Поэтому хардкор доклад тоже отдельно. И вот мы где-то в этих рамках и удержались, что очень приятно. Кстати, вот тоже за то, что ГИФ у нас первый раз, очень приятно, что у нас программный комитет разбавился новыми людьми, которые нам помогли и с докладчиками, и с темами новыми, потому что темы мы стали более объемно рассматривать. И хочется, чтобы были люди, которые разбираются вот в конкретной теме какой-то. И у нас почти под все доклады был кто-нибудь из программного комитета, кто хорошо понимает эту тему и может объективно выдавать фидбэк, с учетом того, что он в этой теме специалист.
Кстати, а вы можете рассказать, вот кто из вас за какую тему отвечает, ну так, в среднем? Вот ты, например, за что отвечаешь?
Мы с Вагифом пересекаемся на самом деле.
Ага.
То есть F-Sharp, функциональное программирование. Персонально я еще неплохо понимаю .NET и тестирование. Потому что с тем и другим я довольно много работал постоянно, в ежедневной работе.
Вагиф, у тебя есть еще что-нибудь для этого?
Ну вот из тех докладов, которые я курировал, несмотря на то, что я сейчас занимаюсь программированием, там были как раз темы с контейнерами, и с вообще архитектурой, то есть там было совокупность вещей, даже, по-моему, чисто шаг функционально больше был на программировании, но по-своему это тоже и как член комитета интересно с этим сталкиваться, вот, и смотрю, как можно представить, совсем мало. Например, я курировал доклад, связанный с космосом. Это, ну, мой личный интерес, как
Окей, понял. А у тебя, Миха?
Я специализируюсь на безопасности, на DotNext, и у нас по безопасности чисто один доклад, это стандарты, но с другой стороны я считаю, что просто достижение международного уровня. Он делает свой первый доклад, и я считаю его действительно одним из лучших специалистов по .NET Security, автора лучших книг.